We will now have a look at some code. This is by no means a complete explanation of all the methods and all the classes you can use. You shall only get a first impression what can be done and how to proceed. The central class to be used is the class Animated GUI Object CV, which represents objects that can be displayed and animated on the screen. Such objects, as we've just seen, have types. They can be views, they can be geometric shapes like rectangles, squares, ovals or circles. They can be texts, they can be polygons defined by paths, and they can be bitmaps, potentially with text, that can be defined by any bitmap file. The type of the object is stored in a property in a field by this name. We can specify whether an object shall currently be visible or not. We can specify the layer at which the object shall be displayed in front or behind any other objects. Very important are the animators registered for the object. We can register any number of animators which can be played and modify the appearance of the object on the display. Objects can have dependent GUI objects like borders around them or lines to other objects or points on the display, which are animated in accordance with the object itself. We can register property changed listeners, which get active when something happens, like a collision with another object. Depending on the type of the object, we have different constructors. Always, a constructor will get the name of the object and will get the initial position of the object to be shown. It might be that we also define an initial color of the object and an initial size. Depending on the type of the object, there may be other constructor parameters, like for example here the bitmap to be displayed or the text to be shown. There are setters which are called to modify, to change the property values of the object and therefore to animate it on the display. There are setters for the location of the object, like set left bound, set top bound, set center X, center Y. We have setters for the size of the object, the width and the height. And we have a setter for the rotation angle. We have a setter for the color of the object. We have a setter for the transparency of the object. And we have a setter for the name of the object. The draw method will then be called by the animation view shown on the display to draw the object on the screen. Very important is the possibility to start the animation of the object. This will start all the animators that are registered with the object. We can play them sequentially or we can play them at the same time. Animators can be added dynamically and also removed dynamically. There are multiple add methods for adding such animators of different types. For example, there are methods like add linear path animator, which will move the object linearly to some target position. The duration parameter defines how long this animation shall take. And we optionally have a start delay parameter defining the initial delay before the animation starts. We can also pass a time interpolator to the add method to specify the timing behavior of the animation. There are also animators to attract the object to a specific point or to repulse it from this point. There are animators to move the object along a path consisting of multiple segments. There are animators moving the object along a Bezier curve, quadratic or cubic. We can move the object along an arc or a complete circle or an ellipse or a spiral. We can add animators to change the size of the object, and we can let it rotate. There are animators possible to modify the color of the object, to let it blink, to let it appear suddenly, to let it fade in and to fade out, and to animate its Z position on the screen. To display objects, we use the class AnimationViewCV, which is a subclass of View. This class defines an array list which contains all the objects that shall be displayed on the screen. We can define corresponding touch listeners and gesture detectors reacting to touch events and gestures. The onDraw method, as on every view, will be called by the runtime system to draw the view, and this will in turn call all the draw methods of all registered objects, like seen here in this loop. Here we have the draw calls of the objects registered with the animation view. We can add animated objects dynamically. We can remove them, and we can sort them by their layer on the screen. The general method startAnimations will start all animations of all objects on the display. Finish by a little example. The example first creates an animation view and then multiple objects to be displayed and animated on the screen. We have a closer look at one of these objects, which is a rectangle. This rectangle is generated. The type is given. It gets a name. It gets an initial color, and it gets an initial position on the screen and an initial size. We define and register two animators, a linear path animator, which will move the rectangle to some location, 1700. This animation will take 5 seconds and it will start after a delay of 1 second. And we define a second animator animating a color change. Finally, we add the object to the view. After doing the same with all the other objects, we display the view on the screen and we start all the animations.